So we are in our final two lessons of Unit 2, 1450 to 1750, and our final two lessons for Chapter 7. And you can look at the bottom here. We have the Scientific Revolution and the European Enlightenment. And they are related to each other. So if you were absent, if you click on this, you will see there's an assignment and a PowerPoint. Now, if I click on Class 41, it is the identical assignment because it's going to take 2 or 3 days, depending, to learn everything we need to learn about regarding this topic. And for these videos, I'm going to separate this PowerPoint lecture with this Enlightenment lecture. So anyway, in the assignment itself, the first two parts are philosophical. We were thinking. We were looking at Clarenceville's science department, what's valuable, what's not so valuable, what should we be learning. And then we applied this debate between science and faith into some real-life applications. So part 1 and 2, no right or wrong answers per se, but I want you thinking. And then part 3, the nuts and bolts of the scientific revolution. Part 4, a video. And then part 5, the Enlightenment. Okay, so again, it's going to take 2 or 3 days. And for now, I'm just going to share with you what we learned in class about the scientific revolution. So, scientific revolution, on the simplest of levels, is a shift from a faith-based to a science-based worldview, okay? And it is controversial. It always has been. It probably always will be. In the last couple classes, we've been having some controversial talks, but I don't think there's anything wrong with that, okay? It's kind of just part of being a human being, where you look at the world, you figure it out, and you come up with your own opinions and values and all that good stuff. So anyway, what was the scientific revolution? It began in the middle of the 16th century, and what we see is that people are using science to explain their world more than superstitious things. And we see the beginnings of modern astronomy, physics, chemistry, biology, which are required courses for many people throughout the world to graduate, because we feel it is important to have rudimentary knowledge in all 4 of those disciplines. And I certainly feel that myself, okay? So for years and years, this is old school. This is not part of the unit we are in, but I think I have to tell the story to lead up to the scientific revolution. So for 1900 years, human beings believed in a geocentric model, geo-earth-centric center. Earth is the center of the universe, and if you use the naked eye, okay, this is the way the world looks. So this is all the way back from Aristotle, okay? So the Earth's the center of the universe. We could see up to Saturn. Outside of Saturn, they had fixed stars and the sphere of the prime mover, which is the great beyond. And this went on pretty much without question for 1900 years. That lasted a long time. And again, these guiding principles: the Earth's the center of the universe, all motion in the heavens is in a circular motion, celestial objects are made from perfect material, cannot change their properties. These 3 principles were pretty much airtight for almost, 1900 years, long time. But we did see some gradual contributions to the stories. For instance, Ptolemy. Now, Ptolemy came up with some ideas about the motion of celestial bodies, but again, it didn't deviate from that geocentric model. It wasn't that controversial, okay? He pretty much modeled what was modeled before him, okay? Now, in the story, Aquinas is hugely important because during medieval times, there were some people who said we need to disregard the prior knowledge of the Greeks and the Romans because they were not Christians, where Aquinas said, hey, listen, you can reconcile these two, okay? This scientific learning can fit into a Christian worldview, and he won the day with that viewpoint. And the reason why this is so important, if he doesn't get that point across, we might have lost all of that prior knowledge, which would have set us back who knows how long. So thank you, Thomas Aquinas, for doing that, okay? But again, Aquinas did not disrupt that fundamental model of what was going on a long time, what the church said was true. Now here's the change. Now here is the unit we are in now. We start with Copernicus. Copernicus, the father of the scientific revolution, this guy here. Now, this doesn't seem so controversial now, but he said, you know what? I don't think the Earth's the center of the universe. The sun is the center of the universe. Now, that seemingly innocuous statement was so dangerous to say, he released his findings on his deathbed so he didn't face punishment from the church for going against what the church said. Now, just a little side note. If you've ever been to the Detroit Main Library, you should. It's an amazing place. And there's an enormous statue of Copernicus as you walk in, as there should be, as somebody who values the truth and science, So anyway, if you've ever seen that big statue, that's who it is. If you've never been there, not that far, go see it. Okay, and again, here's the heliocentric universe. Okay. Now, this guy here, Tycho Brahe, hugely important to the scientific revolution because he said, listen, science has to be measured and it has to be duplicated. So I'll give you an example. I can say vinegar and baking soda produces a chemical reaction. Prove it to me. I can prove it anywhere in the world. I can measure it. So he said that. That's why when you're in science class, everything is in moles and milliliters and liters because of him. It had to be measurable, precise, and duplicated. Now, another man who's important in the scientific revolution is Kepler. Kepler realized that there were rules that the universe were governed by. And you can take his laws, Kepler's laws, and it applies to the universe. And you've probably learned about these in science. I'm going to let your science teachers handle the heavy lifting here. But if you remember Kepler's first law, the orbits of the planets are ellipses with the sun at one focus of the ellipse. Kepler's second law, the line joining the planet to the sun sweeps out equal areas and equal times as the planet travels around the ellipse. And Kepler's third law, the ratio of the squares of the revolutionary periods for the two planets is equal to the ratio of the cubes of their semi-major axes. Okay, so I misspelled axes. That's okay. I'll let your science teachers handle this. Now back to the history. Now Galileo, with this telescope. Now, this is a game changer. That provided the evidence to how the universe worked. And again, that old model was based upon the naked eye. Now we have a tool to see the truth. Now, what Galileo observed was the first time in human history that it was accurate. He realized things were, and what the truth was against what the church said. And when he came out with the truth, based upon the telescope, he faced serious trouble with the church and almost lost his life. Essentially was put on house arrest and was forced to take his viewpoints back. So he suffered for the truth. And in recent years, the Vatican has apologized for how they treated Galileo. But this is a game changer. Then we see Sir Isaac Newton. Now, Newton, similar to Kepler, came up with these laws that governed the universe, okay? And I think you know these maybe better than Kepler. Newton's first law, an object in motion tends to stay in motion. An object at rest stays at rest, unless the object is acted upon by an outside force. I'm sure you've learned that. Newton's second law, the acceleration of an object is directly proportional to the net force acting upon it and inversely proportional to its mass. Again, I hope this is old learning for you. And my favorite one, Newton's third law, for every action has an equal and opposite reaction. So anyway, this is important for this. This is the most important slide because when the scientific revolution kicks in, we see this happening throughout big portions of the world. Number one, skepticism and independent reasoning. I encourage you all to think for yourself, and I encourage you all to question. Question everything. Question authority. Whereas before, it wasn't like that. Obey, obey, obey. For the first time, really, there was encouragement to think for yourself and be skeptical. Okay, nothing wrong with that. Number two, challenges to religion. You could question religion. And again, whatever your religious beliefs are, I hope it's not blind obedience. I hope you've thought it out and decided this is for me. So the first time you could challenge the religion. Number three, decline in the belief of magic and demons and witchcraft. So that kind of hocus pocus stuff, that started declining. Questions about humanity's role in the universe. People started questioning why are they here, and these deeper questions gave humanity control of nature. For example, learning how to, for example, a lightning rod, so it doesn't hit where you are, to, handle nature in a way that's beneficial for humans. And then challenges to the established views of women. If you use scientific eyes on women, you realize they're the same as men in terms of they have a circulatory system, a respiratory system, that kind of thing. So anyhow, so if you were absent, you should be able to complete 1 through 3, and then 4 through 5 will be tomorrow's class. And hopefully you have the basics of the scientific revolution and it corresponds with that section in your book. And that's that. So thank you for watching.